Good day everyone and welcome to our recorded lesson for our General Physics 2. And to start, let's have a simple recall muna of our previous lesson. So last meeting or last time I have uploaded our PowerPoint regarding the electrical safety, the electrical hazards, and as well as mga measuring devices that you can use to measure the electric current or the electrons that is flowing from our wires. So simple recall muna. So when we say electrical safety or electrical hazards, it is any situation that poses a risk of injury or death or even death from electricity. These hazards can range from the minor, like getting shot from a frayed cord, to the very serious, like electrocution from a downed power line. Okay, so here are the common examples of electrical hazards. You have there the exposed wiring, flashing of electric arcs from high voltage, lightning, machinery or occupational related exposure, biting or chewing on electrical cords, and even poking metal objects into an electrical outlet. Okay, so ayan we must be careful, lalo na sa mga kuryente natin dyan. Kapag meron tayong mga exposed na wires, like meron mga wounded kumbaga or sira yung wires natin, dapat asikasuhin natin yun, or hingi tayo ng tulong from nakakatanda para maayos yung ating mga wirings para iwas disgrasya, It's better to be safe than para it's better to be safe compared to kanang mga ospital nandiyan ka, So kaya safety first all the time. And like this one, masyado itong makalat na wirings, and it can be considered as an electrical hazard. Okay? And even this one, I know medyo common ito sa atin ngayon or sa mga houses na kulang yung socket, so kaya gumagamit ng mga extension wires, pero naging octopus kumbaga yung mga connect ng mga extension wires. So this can also be considered as electrical hazards. And lalo na ito, lalo na sa Pilipinas. Okay, as you can see in our streets, maraming mga wires na masyadong makalat. So iba doon na mga wires is galing sa mga cables, sa mga internet cables natin, and most likely din sa mga wires. Yung mga poste din na luma na. So, I don't know kung meron bang action or pinaplanuhan na ba yan ng gobyerno natin para maayos yan. Pero hopefully na maayos yung mga wirings natin. Lalo na yung mga poste natin para iwas disgrasya. Okay, so those are just mga some part of our previous lesson. Now this morning, let's talk about, or this will be our continuation of our module 3, and we will talk about we will talk about this energy and power, the Kirchhoff'S rule, and as well as the RC circuitry. Now before that, let me present to you our learning objectives. At the end of the lesson, the student should be able to compute for the electromotive force in terms of terminal potential difference, internal resistance, and power. Apply Kirchhoff's rules to a given scenario and determine RC circuitry. Okay, so I hope you have your notebooks and pens near you, para maka-take down notes kayo later on. And please watch until the end para prepared tayo for our upcoming exam and para makasagot din tayo sa ating mga activities that I will present to you later on. Okay? So to start, let's talk about first the energy and power. So in the world of electric circuits, energy and power are two key concepts that relate to how electricity is used and behaves. Okay, so on our previous lessons, lalo na sa modules 1 and 2, nalaman natin what causes the electrons or the electricity. Now, this time, let's understand how electricity is used and behaves. So first there we have the electric energy. So it's stated here that electric energy is the converted U sub E. So ano ba itong U sub E na ito? Okay, ano itong U sub E? So U sub E, that is the symbol, or it is denoted, no, for our electric potential energy. So meaning to say, electric energy is the converted electric potential energy, no? So, meaning to say, you can think of it as the total capacity to do work. Yung energy na iyon, okay, that is the total capacity to do work. So, parang lang sa battery, no? Battery is an example of the form of electric energy kasi it holds the potential to power devices. Meaning to say, it holds the potential para gumana yung mga machineries natin. For example, yung flashlight. Okay, gumagamit tayo ng battery. And then yung battery na iyon, meron siyang tinatawag na electric energy. And then yung electric energy na iyon is nakakonvert siya into other forms. So like yung sa flashlight, no? From energy, nagiging light yun siya. Nag-produce ng light yung ating flashlight. And even yung mga cellphones natin, no? Gumagamit ang cellphones natin ng battery. And then those are the source of energy natin, ng phone natin para umandar. Okay? So, ito si energy, it is measured in joules. Okay? Kasi energy nga, di ba? So, usually, ang unit niya is joules. And also, in a circuit, electrical energy is constantly being converted into other forms. So, like light from above or heat from a resistor. So, those are just an example ng ating electric energy, no? So, I hope you understand that. And on the other hand, power naman, hindi yung power ng mga superheroes natin, no? But in essence ng electricity or electric circuitry, power is the rate at which energy is transferred. So, mean to say, no, it is the rate at which yung electrical energy natin is used or transferred. So, kung si electric energy is the total capacity, ito naman si power is not the total amount of energy, but take note how quickly that energy is being used. Okay? So, here, power, energy is transferred to the entire circuit. Okay, na-distribute, no? And since meron tayong source of energy, syempre gagamitin natin yung energy na iyon para maging other form siya. So, yan yung essence ng power, no? How quickly that energy is being used. And si power, it is supplied by generators and batteries. Okay? So, you can imagine, no? Let's say, imagine tayo ng faucet. So, I believe nakita tayo lahat ng faucet, no? So, the wider it opens, yung daanan ng tubig natin, the faster the water, or let's say, yung water na yun yung energy. Okay? So, the wider it opens, the faster the water flows. So, power is like the width. Okay? Yung how wide yung opening ng ating faucet. Okay? So, ito si power, it is measured in watts, okay? Or also denoted by the term na W, okay? Watts or W, okay? Or also, itong watts na ito can be equivalent to joules per second, okay? So, higher power signifies a circuit is using or converting electrical energy more rapidly. So, the higher the power daw, mas higher yung or mas maraming electrical energy ang nakakonvert niya continuously, no? So, the relationship between power and energy is similar to distance and speed. Speed tells you how quickly you cover a distance, while the distance is the total amount covered. So, in conclusion, no? Let's say imagine a light bulb. The electrical energy from the circuit is used to make the filament glow or mag-ilaw siya. But also, it generates heat. So, another energy form din yon. So, the power rating of the bulb tells you how bright it will be or how much energy it converts to light per second. Okay? So, yan lang yung kaibahan ng electric energy at saka ng power. Okay. So, in addition then, energy and power is interrelated to Ohm's law. So, as a recall lang, Ohm's law, it is developed by George Simon Ohm, and current is proportional to voltage and inversely proportional with resistance. So, meron tayong formula na R is equal to V over I. So, when we solve for the power, no, we have this formula, okay? So, take note, power, unit niya is watts. Voltage naman, ang unit niya is volts. Ang current naman, ang voltage niya is amperes or amps. And ang resistance naman, ang unit niya is ohms. Okay, so these are just mga summary, no, of formula para makasolve tayo ng power, volts, current, at saka ng resistance. Okay, please take note of that. Okay, so let's have an example. Given a simple circuit with a current of 5 amperes, determine the power exerted by the dry cell in the circuit. Okay, so let's say we have this circuit. Yan. So we have the source of our energy, which is the battery, and then meron siyang 12 volts. Okay? And based from our problem, meron tayong given din na current. Okay? And current is 5 amperes. So, determine doon natin yung power, no, exerted by the dry cell in the circuit. Okay, so we know, diba, these are the following formulas to solve for power. Okay, so since meron tayong given voltage tsaka current, so possibly, this will be our formula, right? Okay, so therefore, when we solve for the power, we just have I or the current times the voltage. Okay, or vice versa, voltage times current. Same lang yan sila, no? So, meron tayong given na current which is 5 amperes at saka voltage na 12 volts. So, i-substitute na natin yan sa ating formula. We could have 5 amperes times 12 volts. And 5 times 12, that is equal to 60. And since power man ito, therefore, ang unit natin is watts. Okay? So, 60 watts or 60 W. Okay, so ganun lang kadali. Solve for the power. So, if you have question, no, you can message me or you can leave a comment here sa ating video. Okay, so another example. As seen in the diagram at right, determine the power of the circuit. Okay, so another example, we have here a circuit, meron siyang voltage na 45 volts, and this one, 750 meters ohms. Okay, so ano ba itong 750 meters ohms? Okay, micro ohms micro ohms, no? So, take note, ang resistor natin or resistance natin, meron siyang unit na ohms lang. And sa ating given, meron tayong micro ohms. So, we need to convert that, no, into ohms. So, how can we do that? So, simply, 750 macro ohms, okay, divided by 1,000, okay, Mach M, and eliminate yan siya. So, therefore, ang resistor natin, or resistance natin, we have 0.75 ohms na ngayon. Okay? So, we just simply divide itong given with 1,000 M para malaman natin yung resistance lang natin. Okay? So, okay. So, we know na these are the following formulas natin to solve for power. So, meron tayong given, okay, meron tayong given na voltage at saka resistance. And na-convert din natin ito siya. And that is equivalent to 750 0.750 ohms pala. Okay? So, therefore, saan kaya ang gamitin natin ng formula? Okay, very good. That will be P is equal to V squared over R. And substitute na natin lahat ng mga given natin to our formula. We could have 45 volts squared over 0.75 ohms. And input natin yan sa cycle or simplify natin dito. So therefore, the power of the circuit is 2,700 watts. Okay, so don't forget yung unit ha, basta power, that is watts. Okay? So, I hope you understand the difference between energy and power. Now, let's proceed to our next part, which is the electromotive force, or also denoted by the symbol na epsilon, or electromotive force, in short, that is EMF. Okay? So, EMF, though meron siyang force sa term niya or sa name niya, this is not a force no in a traditional sense. Ang force na ginamin dito refers to the potential. We need to say the difference no ng ating electric potential. And take note, in volts yan siya, no? In volts. So, dito sa electromotive force, it worked no for a circuit source. So it moved charges from negative to positive and resulting motion generates voltage in a battery. So ano ba ibig sabihin ni EMF or ni electromotive force? So EMF no is a bit like a push behind the scenes in an electrical circuit. Though it's not exactly a force, but rather the energy transferred per unit charge that gets things moving. Take note, energy transferred per unit charge that gets things moving. So, although EMF or electromotive force has force in its name, okay? Take note, hindi siya yung traditional na force in essence, no? And it is not a pushing or pulling force like a magnet. So, here, it just represents the energy given to electric charges. Kasi sa EMF, it causes no, the electric current to flow in a closed circuit. Without EMF, there's no push for the charges to move. So in essence, electromotive force acts like a pump no, for electric charges, creating the potential difference that drive current flow in a circuit. So push lang siya. Siya yung force, kumbaga, para lahat ng electric currents natin, okay, or lahat ng mga electric charges natin is mag-move. Okay? So, take note, yung force daw refers to the potential or the electric potential difference. And we know that electric potential difference is measured in volts. So, therefore, EMF is also measured in volts. Okay? So, let's say, ayan, meron tayo ganito na schematic diagram. So, how can you solve this electromotive force? So, simply, electromotive force is equal to I, quantity, capital letter R, plus small letter r. Where, itong R natin, capital letter R, okay, yan yung external resistance. Okay? External resistance. I'm sorry for my handwriting. So please bear with me kasi phone lang yung gamit ko no ngayon when I'm recording this lesson. Okay. So another formula to solve for the electromotive force or EMF is we have V sub T plus IR or work of the energy divided by the charge Q, where R is the internal resistance and V sub T naman is the terminal potential difference. Okay, ano pala itong internal resistance na ito? Internal resistance or yung small letter r, it is the resistance of a source, no? And it reduces the output voltage of a source. Take note, it reduces the output voltage ng source natin. And terminal potential difference naman or V sub T, it is about the output voltage of source, internal resistance included. And meron din siyang specific na formula. So, V sub T is equal to epsilon minus IR. So, dinerive lang siya, no, dito from our given problem. Okay? So, ayan siya. So, let's have an example. Given a dry cell with an EMF value of 1.5 volts, determine the current flow it can provide, provided that its total resistance is 0.5 ohms. Okay. Alamin din natin yung current, no? Yung I. Yung hinahanap natin dito. Okay? The I. Determine the current or yung I, yung hinahanap. And ang given natin dito is we have epsilon 1.5 volts. Okay? Ayan o, meron EMF value of 1.5 volts daw. And then, meron din tayong resistance or yung total resistance, meaning to say, external resistance plus the internal resistance that is equal to 0.5 ohms. And ang hinahanap natin is the current. Okay. So, anong formula maaari natin gamitin dito? Okay, very good. So, the formula that we can use for this one is simply epsilon is equal to I times capital letter R plus small letter r. Or current times external resistance plus internal resistance. And we know that epsilon or the EMF is 1.5 and the total resistance is 0.5. So we just simply substitute dyan, no? And then derive natin ang formula para malaman natin yung value ng I. And that is equal to current or I is equal to 1.5 volts divided by 0.5 ohms. And simplifying this one, we could get 3 amperes. Okay? 3 amperes. So, I hope you understand this one, no? Okay, let's proceed to another example. Suppose the circuit have the following. Meron EMF na 12 volts, internal resistance na 0.1 ohms, and external resistance 8 ohms. So, hanapin din natin ulit, no, yung current passing through the external resistance. Okay. So, I want you to do this on your own. Kindly pause, no, for a while, and then do this in your notebook para ma-practice nyo. Okay? So let's proceed to the difference between electromotive force at saka potential difference. So, electromotive force, it is always constant and proportional siya sa stored energy natin. And this is the cause of a voltage's occurrences. While potential difference naman, not always constant, and the charge distribution across the circuit, and it is about the result of a voltage's occurrence. Okay? So, I hope you understand that. And these are just mga list of formulas, no, for the power output of the EMF, power load transfer, total power output, and the power dissipated as heat. So, you may refer to your handouts for the list of these formulas. Okay? Now, let's recall then, no, in the previous lesson natin, we have discussed ano yung resistors at saka circuits. And ano yung total capacitance ng ating resistors, ng ating current, at saka ng voltage natin. So, for instance, we have here the series. Okay? So, in a series na circuit, ito yung total capacitance ng ating resistor. We just simply add all the resistance na meron sa ating circuit. Ito naman sa current. Equal lang siya, no, all throughout sa series natin. Or all throughout sa circuit natin. And for us, the voltage naman, we just simply add then, no, lahat ng given voltage sa ating circuit kapag series. Okay? Pag parallel naman, is ito siya. Ang resistance or the total resistance natin is simply 1 over R sub T, and i-add natin lahat ng ating resistance. And denominator siya ng ating 1. Okay? And for the current, we just simply add all the current. And for the voltage, equal lahat. Okay? And when we draw a schematic diagram of our circuit, is we have these following symbols, no? So you may screenshot this one, or you may take down of notes of this para meron kayong idea, no? Okay. So, yan siya. So, we are done with the electro energy and power, and as well as the electromotive force. And we know, diba, na hindi naman always na series or parallel yung mga circuits natin. Okay? Same sa buildings. Okay? So, paano ba na-design ng mga electricians or ng mga electrical energy engineer natin, no? Na dapat ganito yung arrangement, kumbaga, ng ating mga cords or ng mga wires natin. So, dyan papasok itong Kirchhoff'S rule, no? So, Kirchhoff'S rule, it is first described by Gustav Kirchhoff, and he generalized the works of George Ohm. Kasi diba, kay George Ohm, ang pinakita lang doon is how to solve for the resistance, the voltage, and the current. Pero, hindi napakita doon kung ano yung behavior ng mga currents natin, ng mga resistors natin, and as well as ng ating voltage, no? So, also, Kirchhoff's rule preceded the work of James Clerk Maxwell, that is about understanding, or James Clerk Maxwell understood as the proposition of Maxwell theories. And then Kirchhoff's rule is widely used in electrical engineering. So Kirchhoff's rules are two fundamental principles to govern, or that govern the behavior of electric currents and voltages in electrical circuits. They are based on the laws of conservation of charge and energy and are essential tools for analyzing complex circuits. There are two main parts to Kirchhoff's rule. Okay? So take note ha. Itong Kirchhoff's rule, it is a fundamental principle that govern the behavior of electric currents and voltages in electrical circuits. Okay? So as I have said earlier, there are two main parts to Kirchhoff's rule. Okay? First there we have the junction rule, or also known as the current law, and the second one is the loop rule, or the voltage law. Okay, so let's start with the junction rule. So junction rule, at any junction in an electrical circuit, the sum of currents flowing into the junction is equal to the sum of the currents flowing out. And yung intersection ng ating mga circuit is what we call the junction, or also known as node. Okay? So according to junction rule, or itong current law, all incoming currents must be equal to the outgoing na mga currents natin. Okay? So, meaning to say, kung ano daw yung value ng current na papasok, wait lang, I'm sorry. Kung ano daw yung value, okay? Kung ano daw yung value ng current na papasok dito sa ating junction, okay? This is our junction. So, kung ano yung value na papasok dyan, equal lang siya sa value or amount ng current na lalabas from our junction. Okay? So, in other words, current cannot just disappear or appear at a junction. So, imagine a junction like a traffic intersection, or yung mga toll gate natin, sa Manila, lalo sa Manila, So, the number of cars entering the intersection or yung sa toll gate natin must also be equal to the number leaving it. Okay? So, equal lang siya. Hindi naman din pwede, na kung ano yung papasok sa toll gate is mawawala yung kotse. Okay? Equal lang siya. Kung how much yung amount ng current na papasok sa junction, ganun din yung amount ng current na lalabas. And take note, basta ang current is going in, okay, going in sa ating junction, positive yung kanyang sign. Kapag going out naman siya, negative yung sign niya. Okay? Take note of that. So, let's have an example. Given the diagram at right, determine the value of I in amperes, provided that the given values also share the same unit. So, since this is current, most likely, about sa current lang ito lahat. Okay? Okay. So, another note din, the algebraic sum of all the currents sa junction natin, they are equal to 0. Okay? In any closed circuits, the algebraic sums of all EMFs and potential drops is equal to 0. Or all the currents flowing in and flowing out from our junction must be equal to 0. So, for example, we have current 1 plus current 2 plus current 3. That must be equal to 0 lahat. Okay? Yan yung algebraic sum niya. Equal to 0. Okay, going back here sa our problem. So, meron tayong arrow or diagram, So, for the 5 amperes, going in siya sa junction natin. And this is the junction. Okay? So, kapag going in siya, therefore, positive ang kanyang sign. While itong 2 naman, going out siya, therefore, negative yung sign niya. And same with here, sa 1, na going in. Okay? This is going in sa ating junction. So, that is also positive. Now, ano kaya yung value nitong I natin? And take note, going out siya, so therefore negative siya, Okay. So, to solve for the I, simply, Di ba, kailangan natin i-add lahat ng mga given currents and that must be equal to 0. Okay? So, therefore, we have 5 plus negative 2 plus I that is equal to 0. Okay? Or simply, 5 plus 2, 5 minus 2 plus 1. Okay? And since understandable naman na maging negative ito siya kasi meron na tayong arrow na palabas. Okay? So, therefore, 5 minus 2, that is 3, and 3 plus 1, that is equal to 4. So, therefore, the value ng ating I dyan in amperes is 4 amperes. And then, it is going outside. So, therefore, meron siyang sign na negative. Okay, so double check natin. So, ang going in natin, total niya is 5 amperes. Okay? Ang going out naman natin is we have ito, negative 2 and negative 4. Yung nasolve natin kanina. So, sorry, nakalimutan ko pala ito. Oh. Meron pa palang 1. So, plus 1 amperes. So, that is equal to 6 amperes. Okay? Ang going out naman natin, okay, so we have negative 2 amperes minus 4 amperes. That is also equal to negative 6 amperes or 6 amperes. So, kita nyo, equal lang yung amount ng current na papasok sa ating junction sa current na lalabas. Okay? Ganun lang yung junction rule. Intindihan ba? I hope na intindihan, no? So, if you have any question, you may ask me or comment down sa ating video. Okay? So, ayan siya. Another example. Given the diagram below, determine the value of I or the current in amperes provided that the given values also share the same unit. Okay, so meron na tayong given from our problem, no? Ayan. Meron tayong mag-given na voltage, resistors, at saka current. Yung hinanap natin dito is the current. Okay? So, take note, we can use yung Ohm's law dito kasi we are looking for the current. And meron tayong given na voltage at saka resistor. So, paano ba yan? So, given the diagram below, determine the value of I in amperes provided that the given values also share the same unit. So, for the current, okay, going from here, itong point B to E natin, point B to E, we have the formula na I is equal to VR. And I, yung current from B to I, equivalent din siya sa first current natin, no? Yung nandito sa diagram natin. Ito, oh. Equal lang yan siya dito. Itong yellow na arrow na ito, going from B to I. Okay? So, to solve for the current, we just simply have the voltage na 24 and the resistor na 8. So, bakit 24 yung voltage? So, take note, ito. We have voltage 1, which is 12 volts, and voltage 2 is 12 volts. So, 12 plus 12, that is equal to 24. Kaya, 24 yun siya dyan. And 24 divide 8 is therefore, that is equal to 3 amperes. And same process din, no? Dito sa ating from point C to D, or itong I sub 2 current natin. Okay? So, ganun lang din ang process. So, we have V over R sub 2, that is equal to 24 divide 12, and 24 divide 12, that is 2 amperes. So, therefore, itong current 1, or itong first arrow na color yellow, meron siyang how much current? That is 3 amperes. And the second one is 2 amperes. Intindihan ba? I hope na intindihan, no? Okay. Another example for the junction rule, or yung current law natin. So, kanina, okay, parallel circuit ito siya. And same here din dito, parallel yung circuit. Okay? So, how can we solve? So, take note of this, no? When we have parallel na circuit, yung resistance niya is simply, ito yung kanyang capacitance. 1 over R sub T is equal to 1 over R sub 1 plus 1 over R sub 2, and so on and so forth. Okay? And ang voltage naman is equal all throughout, and the current is we simply add all those things. So, first, we need to determine the resistors needed to be unified in one variable. And ito yung diagram natin, di ba? So, ano daw yung resistors? 1 at saka 2 natin. So, saan ba yan galing resistors 1 and 2 natin? So, ito yan siya, no? Meron tayong symbol there na R sub 1, that is 2.4 ohms, and R sub 2 naman, or resistor number 2, is 1.7 ohms. And that is 1 over R from resistors from point A to C. Yan siya, no? And for resistors from point C to F naman, we have 1 over R sub 3 plus 1 over R sub 4 and plus 1 over R sub 5. Okay. So, ito yung ating resistors from point A to C. So, resistors 1 and 2, we know na ang R1 is 2.4 ohms and R2 naman is 1.7. So, to solve for the R, we have this one, 4.08. So, asan galing to 4.08? Okay? So, take note kapag mag-simplify tayo, okay, naka-fraction kasi ito, no? Hanapin natin yung LCD nito. Ang LCD niya is 4.08R. Okay? Kaya, pag i-distribute natin to siya, we could have, ayan, distribute natin niya siya, ito yung iwan, 4.08. And i-distribute natin dito, so 4.08R divide 2.4, that is equivalent to 1.7R. And this one then, 4.08 divide 1.7 is simply 2.4R. And add all this thing, we have 4.1, and since we're looking for the R, so we divide both sides of the equation with 4.1 I mean. So 4.08 divide 4.1, that is approximately 1 ohms. Okay? And for the resistors, 3, 4, 5 naman, same process na pa rin. So for resistors 3, we have 60 ohms. Resistor 4, we have 20 ohms. And resistor 5 is we have 30 ohms. Okay? And simplify that, we could get an approximately 10 ohms, no, for the resistors from point C up to point F. Okay? Now, so to add all the resistance natin, we could get 11 ohms. And therefore, for the current is we have 132 volts divide 11 ohms. So therefore, we have 12 amperes. And the voltage from point A to C is simply 12 voltage, and same with, no? So dito naman sa voltage from C to F, we have 120 voltage. Okay? Naintindihan ba? So if you have question, please leave comments or message me. And next, we proceed to the second rule ng Kirchhoff'S rule, and that is voltage rule, or also known as voltage law or loop rule. Okay? So according dito, the sum of voltages encountered in a complete traversal of any loop of a circuit or mesh is 0. So it talks about the voltage, no? And kung ang algebraic sum ng current natin is equal to 0, ganun din dito sa voltage rule. The sum of voltages encountered in a complete traversal of any loop of a circuit is also 0. So this law states that the algebraic sum of the voltages around any closed loop in a circuit must be 0. So inulit lang, no? And take note, we are moving from high potential to low potential dito sa voltage, okay? So for example, we have a resistor. Okay, ito yung symbol ng resistor, di ba? So, from high potential to low potential. So, from positive to negative. Nag-reduce kasi yung ating energy, no? Kapag nag-flow siya dito sa ating resistor. Okay, nag-reduce. So, kaya, ito, we have positive indicates node with higher potential and negative indicates node with lower potential. So, voltage rule or voltage law is an imaginary loop, no, that is traced in the circuit or mesh. Okay? So, voltage rule, so you can think of it as a closed loop, like a circular path around the circuit. As you travel around the loop, the voltage changes due to the sources yung batteries natin, and as well as ng resistors. This law says that these changes must add up to 0 in a complete loop. So when we use Kirchhoff's voltage law, no, you need to consider the signs of voltages. Okay? And Kirchhoff's rules are powerful tools for understanding and analyzing electrical circuits. And by applying these rules, you can predict how currents will flow and voltages will be distributed with the circuit, allowing you to design and troubleshoot electrical systems effectively. Okay, so here are some additional note, no, for voltage rule. So for the resistance rule niya, if the traced loop follows current flow, okay, same direction ng yung loop sa current flow, we could get this voltage. Simply negative current times R. And then kapag yung traced loop naman natin counters current flow, okay, opposite direction yung loop flow sa current flow, so we could simply have V is equal to I times R. And for the EMF rule naman, kapag same direction yung loop natin sa EMF flow, so epsilon or electromotive force niya is also equal to itself. And kapag counter naman is, ayan siya, E is equal to negative E. And an additional note, given a circuit with a traced loop with loop countering flow, di ba, yan siya yan. Yan yung kanina. If traced loop counters current flow, then V is equal to IR. And E follows traced loop is, ayan, E is equal to E. So therefore, V is equal to E, or simply, V plus IR is equal to 0, where E is a part of voltage summation equation, and the total voltage must be equal to 0, and IR value depends on E's sign. So let's say we have this diagram with the current loop traced in the circuit. Give the appropriate formula that applies to it. So yung formula natin dito, since nag-counter siya sa flow, okay, it counters. Yung loop natin, counters sa flow. Ay, nag-counter ba siya? Hindi pala, no? Nag-follow lang pala siya. Same sila ng direction lahat. So therefore, ito yung maaari natin gamitin na formula to solve for the voltage niya. Okay? So, ayan. And another one is this. Another example. A circuit is drawn by a physics professor in STI. He sketched out the diagram which is shown below. The total resistance of the circuit is 25 ohms and the total current is 8.8 amperes. Determine the second current and determine the resistance of the resistor. So, this is a parallel circuit, no? So, ano daw yung current at saka yung resistance of the resistor natin? Given yung total resistance na 25 ohms and ang current na 8.8 amperes. Now, so to determine the total current, we know na ito yung formula natin, di ba? We have V plus IR is equal to 0. So to determine the total current is simply V plus E is equal to 0. And E is equal to negative V. Okay? And V natin can be also solved using negative I2R2. So therefore, ang total current natin dito is I2R2. Okay? And to determine the second current naman is simply we have this one. Since epsilon natin or yung force natin is equal siya sa I2R2 and meron tayong given na 220 volts. Okay? Yan yung EMF niya. And meron tayong current na, resistance na 75 ohms. So therefore, ang current natin is equal to 2.93 amperes. Okay? And to determine naman the resistance of a resistor, so simply, same pa rin yung kanina, I1R1. And we know na meron tayong given na epsilon or yung force natin, or yung energy natin, which is 220 volts. And we're solving for the resistor, di ba? So since the total capacitance ng ating current is simply adding all the currents available or given sa ating circuit, so therefore, our resistance or R sub 1 is simply 220 volts divide IT minus I2. So therefore, to determine the resistance of resistor R1 is we have approximately 37.48 amperes. I know, 37.48 ohms. Okay? So that's it. That's for the Kirchhoff's rule, no? So lastly, we have the RC circuitry. So RC circuitry is a circuitry that combines both resistors and capacitors. So RC circuitry can be used to filter signals and block certain frequencies while permitting the others. So from high pass to low pass, yan siya, no? So meron siyang mga components na resistors that resist the flow of current and capacitor that stores electrical energy in its electric field. So, if we have RC, okay, the charging na process, these are the initial state niya, steady state at saka transient state. So, kindly read that one na lang. I will leave that to you as a reading assignment. And for the RC discharging naman is this one. Okay? And that's it. So, as for your assignment, please do this activity. And I will just further announce sa teams natin kung ano yung gamitin niyo or gawin niyo. Okay? So, that's it. So, ayan na siya. So, ayan lang siya, class. Thank you for listening. I hope you learned something well today. Or, I learned something well. I hope you're doing well and I hope you learned something today. So, please, stay updated on our MS Teams. Okay, thank you and God bless.